we'll try to quickly go through all the 3 example problems that we tried to solve before and see how we can solve them now and if we can solve them. So we'll start with the sum of numbers, the first one. So let's rename this tab, call it sum of integers. Okay, so as you remember, we have just, the problem is basically to calculate the sum of all integers starting from 1 to a given n. So we start with taking the input, which is our number, the upper bound of the range, and then I think last time we also solved this, assuming if we know the formula, we can say the sum is equal n times n plus 1, and then divided by 2, and then we can say output sum. So this is one. I think this was the only solution that we could do from all the 3 problems. So, you know, I think going forward I'll keep this convention of ending all the statements with a semicolon. I'm used to it because that's how things are in C++, Java, C#, and many other languages. So I'll just keep this. Let's agree that every statement will end with semicolon. Okay, so this is one way of solving this, and let's assume we don't know the formula and we need to solve this. So again, we take the input and then we need to calculate, basically we need to add up all the numbers from 1 to n, and as you remember, basically we need to add n times, right? We need to loop basically, or iterate through all these numbers and add them. So we take sum as 0 initially, and then we say we'll use basically the count based loop. So we'll say int I equals from 1, and then I is less than or equal to n, and then just increment I. So this, as you remember, curly brackets are used for blocks. So even if let's agree that even if we have one statement, so we can ignore the blocks, but we'll always use them for just clarity and easiness to read, ease of basically readability of the code. So we say sum equals sum plus I, right? I is the next current number from this iteration, so this will give us the sum, and then at the end we say output sum. So this does the job. And if you remember, we also know that we can use this shorthand assignment, so we can say sum plus equals I, which is exactly the same thing. So what this does is basically initially assigns 1 to I, and then the condition it will check is I less than or equal to n. So in case, assuming n is always at least greater than or equal to 1, this will execute at least once. So it will do sum plus equals 1, and then increment the I, perform this last part of the for loop, and then go check the condition again. So 2, if 2 is less than or equal to n, then add, and so on until it has n. So n will be the last number that will be added to sum, because n plus 1 will not be less than or equal to n, so it will just not do, it will end the loop and then output the sum. So this is a simple, so since we know the loops, now we can do a lot more things. Okay, so this is the solution for this sum of integers, n integers from 1 to n. So let's go to the next problem, which was, let's call it orange juice. And the problem, as you remember, was to count the number of boxes of orange juice from a lot of boxes of various flavors. And if you remember, the problem here was we didn't know how to input, right? We assumed there is some special object, which is this boxes, let's say boxes equals input. So we don't know how this happens because we don't know what is this type boxes. We just assume there is some special user-defined type boxes, which is a collection of boxes, and this the boxes with small letter is the variable name. And then we say somehow we input that object. Okay, so this one we don't know yet. This knowledge we don't have, so we have to learn this yet. But assuming we can get the boxes, and assuming each of the boxes has this property or the property or setting, or let's call it property. So if it has the flavor, and we can access the flavor by using this dot notation, box.flavor, so then we can basically check if this flavor is orange or not. So since now we have knowledge of this control flow statement, if we can say if boxes, and then remember we agreed that there is some way of getting the ith element, so let's call it get I, and then we can do flavor equals orange. So this will give us the basically the statements in this if will execute only if the ith box has orange flavor. So as you see, we didn't define I yet, so that's one thing. And also we need to repeat this check for all the boxes, which means again we need a loop statement, and since we need the I, we do count based. But in this case, if we assume boxes is some sort of collection, we can do collection based. So we can do for each box in, and we have to specify the type, or we can say var depending on the language. So let's assume this works in boxes. So basically this says for each box, and then we move the condition check inside the loop because we need to do that for each box. And then we say if the flavor is orange, we need to increment the count. Again, we didn't have the count stored, so we need a variable here to store the current count. So we'll say int orange total equals 0 because we didn't count anything yet. And then if we encounter an orange flavored box, we say orange total ++. Okay, and then at the end we say output orange total. So what this will do basically, this one we don't know yet, but we assume we can do something like this, and we can do, but we don't know yet how. We'll learn it later. So we take input a collection of boxes, and then we just create a variable where we will store the final result, which is the count of the boxes with orange juice, and then we iterate through all the boxes in this collection of boxes, and then check if the flavor is orange, then increment, and then at the end we just output. So this is simple now that we have the knowledge of the for each and if. This seems really simple. So one small thing I want to mention, note that I use the prefix increment, so ++ orange total. So if we do orange total ++, this basically will do the same exact thing, except that this operation will be a little more costlier, because if you think about how this is implemented, is basically it would do, since the result of evaluation of this expression is the value of orange total before increment, it should store that value in a temporary field somewhere. So it basically is something like this, right? Var, or if it's orange total is int, in this case it would be int. It would be previous value equals orange total, right? So basically I'm trying to describe how this would be implemented, this operation of the postfix increment. So it would take the current value, and then it would do orange total increment by 1, and then it would say return the previous value. So we don't know what is returned yet, but we'll get to it. But in case of the prefix increment plus plus, since it returns the value after increment, we don't need this temporary variable. So we can say orange total plus equals 1, and then return orange total. So basically if you don't need the previous value in this expression, the prefix version is always more optimal. So the modern compilers take care of, they actually do a lot of optimizations for us, so we'll get to that, but most likely in all the languages now, these two statements will translate into the same exact code. So, but as a habit, I'm used to writing this prefix when I can. So just for your information. Okay, so this was the second problem, and now we have a solution for it. We count the number of orange boxes. The only missing part is this, how we define this type of boxes, and also how do we define this function or property to access the flavor and to access the ith box. So in this case, actually, we changed from count base to collection base. So this is wrong now. We don't have an I, so we have a box, right? The current box. So this is the right version. Okay, so this will give us the output, the total count of orange juice boxes. Let's go to the next problem, the last one. And the last one was, let's see, rename square root. Okay, so remember the problem with this was int n equals input. So we take some integer as an input, and we need to find the square root of this number, right? And then we talked about two different algorithms for doing this. One is, let's start with the simplest one, right? We start from, so we basically iterate through numbers 1 to n, and then not assuming, but like we know that the square root of n, and we assume n is positive. So the square root of n is always between 1 and n. I mean 0 and n if n can be smaller than 1, but let's try doing this. So so we just do a count based loop. So starting from 0, actually, you know what, let's just assume this n is a root. So let's for now assume that n is actually a square. So it's either 9, 16, it's not something that, so the square root of it is also an integer, basically. I'll tell you why we make that assumption now. So we'll start with 1, right? So let me write a comment here. N is a square of a positive integer. Okay, so we start with 1. We say until is less than n. So it doesn't make sense to check n, because n squared can never be equal to n for a positive n. And I mean except 1. So if n is 1, yeah, let's do this. And then increment I. Okay, so for each one, what we need to do is, since we know n is a not perfect, but a square, so we can say if, and then the square of I is equal to n. So always pay attention to this equality. Remember that equality is written with two equal signs in most languages. Usually if you just do one, it will be assignment. In this case you cannot assign to this multiplication expression, but anyway, so equality is two symbols. So we are saying if it's the square of I, then we found basically, right? We can say output I. And then remember this statement or keyword that said terminate the loop, right? Because we already found the result, the one we are looking for, so we don't need to continue anymore. So we can say break. That's it. So break means exit from the loop, and then since there are no more statements after the loop, the program will end. So this is a solution in its simplest form, assuming that n is a square of an integer. So now if we think about n being not a square, let's say n is 10, right? So the square root will be will not be an integer, it will be a rational number. And in that case we can do multiple things. So first we can start approximating, basically calculating the next digit after decimal point using the same approach. So basically we'll find so first of all we'll go through integers, find the largest integer that the square of which is less than or equal to n. So when we find that, we'll start doing the same loop 1 to 10, not 1 to n, but 1 to 10, or 1 to 9 in this case, for decimal, for the basically first digit after decimal point, and then calculate. So imagine, let's say, if we take 10 as our input, and then we take 10 as our input, so we do 1 times 1, it's 1, okay, it's small. So let's go 2 times 2, it's 4, it's still small, less than 10. So we do 3 times 3, it's still less than 10. So we do 4 times 4, it's greater than 10. So 4, we don't need 4. So 3 is the last one, or the largest number that is still less than 10. So we take 3 as the whole part, right? And then we say, okay, the second loop will do this. So we take 3.1 and multiply by 3.1. So if this is smaller than 10, it's fine. Now we do the same thing with 3.2. If it's smaller, we do 3.3. So we repeat this until the next number, so 3 point some x, right, is greater than 10. And then we take 3 point x minus 1. And then for next digit, we for next digit we can repeat this, and we can get the precision as close to the answer as we need. So this is one approach. I'm not going to write the code. This is a good exercise actually. You should try solving this, so getting at least like 3 digits after the decimal point. Okay, and the second solution or second algorithm, remember this Heron's method, which said every time basically we take Ri, which is root I, in ith step we are saying is R I minus 1. So this is approximation in the previous step, plus n divided by R I minus 1, and all this thing multiplied or divided by 2. So this is every time we do this, we get a little closer to the actual solution. And again, so remember we thought about accepting an input, some error amount, like maximum amount of error, acceptable error. So we can say int n equals input. This is the number for which we need to find the square root, and then we also take some double epsilon, which is the, or let's call it error, and again input. So this would be like something, let's say it might be this, right? So it's 1/10,000th, and So ideally the error would be the difference between square root of n and our solution, but to make it simpler, let's do that. Let's assume we are looking for a solution r for which, let me put this in comments so that you don't think this is code. So for which the r times r minus n and the absolute value of this, so I'll just do this, absolute value of this is less than, or we can say less than or equal error. So we'll assume this will be considered a good solution. Okay, so how we'll get to this, and we know the formula, right? This is Heron's method for getting the square root. So what we can do is we'll use a loop, condition-based loop, right? We say while, so we have the error as input and we have n as input. So we can take the first approximation, right? We can say r1 or r, let's do double r equals, we'll start with n divided by 2. And in this case, see, I put a decimal point after 2. So this is basically to mention that 2 is not an integer here, but a double, a floating point number, so that the result is also a double. So the result of this expression will be double. If I omit this 2, so if I write this in some languages, this might result in an integer. So if it's like 5 divided by 2, it might return 2, not 2.5. That's why we explicitly say I want a double result. Okay, so this is the first approximation, which is half of n. And then we say while, and this condition applies, right? So we need while, or this condition doesn't apply. So we say we don't have a method to calculate the absolute value, but we can do it. I'll show you how to do it. Let's assume for now we can do absolute, and then r times r minus n, if this is, so we need the opposite of this, right? So while the opposite is true, so if it's greater than error, okay, well, while we are not within the error boundary, we keep doing this, right? We say r equals, and then use this formula. We basically just say r plus n divided by r and divided by 2. Okay, so this will repeat, right? So r will change its value, and then it will continue, it will check this expression again. So it will continue until this is not true. So this is not true, it means this absolute value is now less than or equal to error, which is exactly what we want, which means once that is true, once our condition is met, this loop will stop. This statement won't be executed anymore, and we can just output r. So this will be the square root of n with the precision we are looking for. Let's see, what did I miss? Okay, yeah, the absolute. So last point. So let's remove this part for now. So one way to implement this absolute, right? So what is absolute? It's basically take the value of the number if it's positive, and then take the negative value or the minus that value if it's negative, and 0 can fit in either case. So we can say if, so we can have input and then say it doesn't have to be int, but let's assume int x equals input, and then we can say if x is less than 0, then, so let's say int absolute equals x. Okay, so if x is less than 0, then we say x equals minus x. or minus absolute to be more explicit, right? So these 6 lines basically take an input and then calculate the absolute value of that, right? So first we assign x and we check if it was negative. If the input was negative, let's do this. Okay, then we say, okay, no, the absolute should be the inverse, or the minus whatever value. So we don't check the positive, because for positive we would just assign the input, and we already did that. Actually, no, this should have been x, sorry. So x is the input, absolute is the output, right? So here we can say output absolute. Okay, I think I have mistaken all this. Absolute equals minus 6x is our input. Yeah, I picked bad names. We'll dedicate another video to naming. That's very important. But anyway, so we have a way we can basically remove this input and output and put this code inside this method to replace this absolute with to basically calculate this absolute value here before going into this condition. So that's it. We have the solution. Yeah, we basically now, since we know all these control statements, loops and conditions, it's much easier to make to solve simple problems, and we can solve them in different ways. Again, first, the important thing in every problem solution is to understand how you're going to solve it, because if you don't know how to solve it, doesn't matter how many statements you know or what languages you know. So the important part is understand how you would solve it, what algorithm you would use, and then after that, translating that understanding into the programming language is the second problem, and it's the easier problem if you know the language. So that's it. Yeah, we have the solutions for the 3 problems. We'll use the 3 problems for a couple more advanced topics when we get to those, but from now on I'll keep adding more and more problems, getting a little more difficult. This might seem very simple, but they have some useful things to learn from. Okay, thank you very much. See you in the next video. Bye.